Now, let's look at on the handling the missing data. All right. Previously, we have already mentioned there are a lot of missing data in any data set. All right. Um, First of all, we have to check which columns or which attribute has the missing data. For that, we can use this method called isAny. IsAny give you the value true if it is a NaN value or false if it's not a NaN value. All right. Then you just need to use another method called sum. So to combine to count all the numbers of NaN values. All right. So let's see an example. Here, I check for two data set. The first data set is a donut data set. All right. Donut data set doesn't have any missing value. So df dot is a dot is na dot sum give you all zero. All right. There's no missing value. But if you look at on our traffic data set, all right, you can see that there are so many missing data here. Okay. So each attributes are like for example like driving license number you have over 19,000 missing record, right, missing values, and then but offense date don't have any missing values, right. Later we will explore more on this driving license data set. Okay, so what are we going to do, right, if we find the missing data? First of all, we have to check the data source, all right, who is a primary or secondary data source that you have collected the data and you verify with them, right. But if the data is not verifiable or like the source is not contactable, you cannot get the data for some reason, you have to think of whether you want to replace or you want to remove this attribute. All right. So sometimes we can predict, we can estimate the value. In that situation, we will use the replace method, right? We will replace it. We will replace the NaN value with a certain value. All right. So for numerical value, you can replace with either an average value or median value. But for categorical value, you usually replace with the most frequent occur value. All right. Let's look at an example and we do it. So traffic data set has been read as a DF in your exercise, right? So first, let's check uh, the missing data. All right, let's check with the missing data. So we will use there is NA. Okay. So here you can see that there are many missing data in this data set. All right. So all the data set, exact amount and hours, we have all the missing data, often days, right? We have all the missing data. Okay, now let's check the data type for each column. All right. So when we check the data type of the column, we can see the driving license number, vehicle numbers, vehicle type names, all these are object. Amount, age are in the given as a numerical and the rest are the object. All right. So driving license number, even though there are missing data in the driving license number, it is a best practice to call the source to check what is the driving license number, right? We shouldn't predict the driving license number. Okay. But then look at the vehicle type, right? Vehicle type. So let's start with the vehicle type name, all right? So for the vehicle type name, we can see what are the information inside the vehicle type name, all right? Let's start with vehicle type name. Okay, so let's have a look. Right, what are these? Okay, so vehicle type name is given like heavy vehicle, medium vehicle, light vehicle. All right. So for this column, we are going to replace with most frequent value. All right. So to find out what is the most frequent values, let's use the value counts. Okay, value counts. All right. So what does a value count give you? Okay. Values count give you the number of vehicle types uh, given in the data sets. All right. So here we can see that there are 55,381 records for the light vehicles, 12,770 for the taxi, and so on. All right. So we can pre-assume that, okay, safely assume that those that we have the missing data, right, the record without the vehicle type, it probably is the because of the light vehicle, right? And this assumption, we are going to find out the we are going to replace, all right, for this column missing value with the light vehicle. Okay, we are going to replace with this. Right. Okay, let's replace with this. When you are using the fail N8, it is very easy. Fail L8, all right, N8. So NaN value will be filled by the string given in your bracket, all right, as an argument. So we keep here light vehicles as an argument. So all the NaN value will be replaced with light vehicles, all right. Okay, now let's see what happened. Okay, I'm going to replace everything here. All right, so let's run this. Right. Now let's check again on the NaN value. All right. See, vehicle type name became a zero. There's no missing value under the vehicle type name. All right. So for the categorical value, if the value is safe to assume, all right, we can take the most frequent occur value and replace the missing value with the most frequent occur value. All right. Here, to find out what is the most frequent value, we use a value counts. Another way is to use the mode. All right. So let me show you another example. How can we do the to check which one is the most frequent occur value? All right. So for this, we will use the mode. Okay. We will use the mode. All right. So most frequent occur value. Okay. So in this frequent occur value, right, we use a mode. Okay, this is a result you will get. All right, you can see the frequent occur value is given like a series, right? So it's a type of data frame. So here, what we have to use is we want to just extract the live vehicle, which is located at index 0, right? So we will extract this. It's a live vehicle. Okay, once we get this value, we can replace this one. All right. So similar to this one, instead of typing the light vehicles, we will use mode value to replace it. Okay, this will give you the same effect. All right, let's check again. All right, there's no missing value under the vehicle type name. Let's check the numerical values, right? Here, again, we will check the data types of the column, right? Attributes. Okay. So we are going to work with the amount and age. These are only two numerical values we have, right? So if you look at the amount, there is no missing value, all right? For age, we have 19,230 records, don't have any information about the age, all right? So let's look at on the age. What are the values inside this age, all right? So this gives you the age value. All right. Some of the record is missing. There's no age information. So for this, what we want to do is we want to replace with either mean or median value. All right. Either mean or median value. Okay. How do we know whether we should use mean or median value for numerical replacing? All right. If you have many outliers, the suggestion is to use a median. All right. If no outliers, we can use a mean value. Okay. So now in this example, we will use the median value, right? We will start with the median value. For example, let's see the median value. Okay. You have age dot median. All right. Okay. Oh, I made a mistake. All right. All right. So median value is given as 36. So similar to example just now, right? We will replace this age or the missing value in the age column with the median values, right? So here the column is age, right? We will replace with the median value. We replace with median value and then we will check how whether we have successfully replaced it, all right, by using the is. You can see that there's no more missing record in the age column. Right, this is how you can do it. Another way to do is, of course, using the median value, mean value. All right, so let's check the mean value. Okay, similar to median, we can use a mean value. All right, mean. All right, we'll call it age mean. Okay, so let's check the mean value. All right. Here, mean value is given as 37.4. So instead of putting with the median, we will replace with mean. All right. Okay. So same way we can use it. Phi and A, and then the variable that we want to replace with, and this is the result. All right. So there is no missing value in your age column. You can use either median or mean value to replace the missing values with the missing value in the numerical data columns. All right, now let's see how we can remove. All right, just now we have already mentioned that some of the attributes you can replace by guessing the number, but some of the attributes are very sensitive data, so you cannot really replace it. All right, for in that instant, if we cannot contact the source, we might want to remove the record. Okay, so for removing the record, what we can use is we can use a drop NA. All right, if we use a drop NA, all right, then if I take exit as a zero, that means for the record. Okay, all the records with the missing values will be removed from this data set. All right, so let's look at this. So drop NA will remove it. All right, to check again, let's check the this NA. All right, okay, so you can see that all the column had only zero missing values. All right, but we can see that there are number of records have been reduced. Okay, for that we can check by using pf dot shape. All right, so if you use a shape attributes, you can see only 3,852 records are being left. This is not a very good way because some of the attributes we might still want to keep. All right. Here, whenever there's an NA, NaN value in your one record, it will be removed totally. Okay. Now, let's do it again. All right. So let's read the data. Okay. Instead of using the draw NA, how we can use to remove particular columns or particular rows. We have already seen that using the drop NA is a bit dangerous, all right? So especially when you have a lot of missing data in your data set, you might be dropping everything, all right? So now instead of dropping only one, using all the missing value, we were trying to drop the particular rows and column, all right? So first, let's see which column we want to drop, okay? So let's read the data frame again, all right? And check how many missing values for each column. All right. So here we can see that the highest missing number is found in the base office name and place of inspection. All right. Okay. Let's check what will be the percentage. All right, for this attribute. Okay. So as we suspected, base of it name and place of inspection has more than 70% missing record. All right. So we may want to draw this particular column. Okay. How do we do it? All right. We will use the column drop instead of draw and name. We will use a drop. All right. This time we are going to drop base office name. Exit one. All right, exit one is to indicate that it is a column. Okay, and then we will use another key called in place equal to true. In place equal to true is to not to create a new variables. We just replace the original data frame. All right, let's see what happened to your data frame. So we have removed it. All right, but let's check again because it's hard to see the table. So we will check the only the columns. All right. So if you check the columns, all right, where do I make the mistake? Okay, we have the, oh, right, sorry, because the column has already dropped. If we drop it again, then you will get the error. All right, so that is because I was using the in place just now. Okay, let's do it again. All right, let's read the data frame again and then do it. Let's remove this stuff. All right, let's read the data frame again and then let's drop it. All right. Okay. All right. So you can see that df dot colon the has already removed. All right. So you don't have the base office name anymore. Okay. Now I'm going to draw one more column, which is place or inspection, and then see whether you have the same column out there. All right. So this time we will remove place or inspection. Okay, place or inspection, and then see what are the column here. Okay, there's no more place or inspection. All right. So if you check the df dot info again, these two column will be missing. All right. There's no more column. Okay. So we only left with 15 columns. You can see that. All right.